In this video, we will discuss CNN, FNN, GNN, PNN and RNN through the lens of cricket. So let's get started with what are CNN or convolutional neural networks. So basically these convolutional neural networks are a type of artificial neural network used for image recognition task. And they are designed to process and analyze visual information and are particularly effective in identifying objects and features within images. So in the context of cricket matches, CNNs could be used to analyze and recognize specific types of shots played by cricket players. So let's break down how CNN might recognize a specific type of shot using the example of cover drive shot. First is the input. The first step is to feed the CNN an image of cricket player in the act of playing a cover drive shot. Then comes convolution, where the CNN applies a set of filters to the images, which are the small matrices of number, and these filters scan the image looking for patterns and features such as the shape of the bat, the position of the ball and the movement of the player. And each filter slides across the image, analyzing small portions of the image at a time. And this process is called convolution. After convolution comes the pooling, where the CNN performs a process called pooling, and pooling reduces the spatial dimensions of the image while preserving important features. For example, the CNN might keep the highest activation function or the most important features from each sections of the image. Then comes fully connected layers, where the image is transformed into the set of features that CNN can use to make predictions. And the features are flattened into the one-dimensional array and pass through the series of fully connected layers. Now these layers are similar to the traditional neural networks, where each neuron is connected to every neuron in the previous layer. And then comes the output layer. We know the final step is to output a prediction. So in the case of recognizing a cover drive shot, the CNN would output a probability score indicating the likelihood that image shows a player playing a cover drive shot. So to summarize this, we can say that CNN processes visual information by applying filters to the image, identifying important features and using those features to make prediction. In the context of cricket matches, CNN could be used to recognize specific types of shots played by players, which could have applications in coaching, training and analysis. Then comes feed-forward neural network. Now this feed-forward neural network are a class of neural network where the information flows in one direction, from the input layer to the output layer without looping back. Now this term feed-forward refers to the unidirectional flow of information in the network. In the context of cricket match, feed-forward neural networks can be used to predict various outcomes based on the input features. For example, feed-forward neural network can be designed to predict the probability of team A winning the match based on the factors like team's batting, bowling strength, the quality of the pitch, the weather condition, and the playing history of the team. So let's take a simple example. Imagine a feed-forward neural network designed to predict the probability of team A winning against team B. Here the network takes as input features like teams A recent performance, team B's recent performance, the pitch condition and the weather forecast, and then the network processes this information and outputs a probability representing the likelihood of team A winning the match. Here the feed forward neural network consists of input, hidden and output layers, where the input layer takes in the features mentioned, then the hidden layers process the information using mathematical operations, be it dot product or nonlinear activation, and the output layer provides the probability of team A winning the match. So to summarize this, we can say feed-forward neural networks are a neural network where information flows in a single direction, from the input layer to the output layer without looping back. In the context of cricket match, feed-forward neural networks can be used to predict various outcomes based on the input features such as the probability of team A winning the match. Next comes graph neural network. Now this graph neural network are a type of neural network designed to analyze and process data represented as graphs. Now these graphs consist of nodes connected by edges, and graph neural network are particularly effective in modeling relations between the nodes in a complex network. So let's take a simplified example from the cricket match domain to explain how graph neural networks work. Analyzing the relation between the players on a cricket team. So first we'll have a graph input. The first step is to feed the graph neural network a graph as input. So in this case, the graph would represent the relations between the players on a cricket team, and the nodes would represent players and the edges would represent connections between the players such as the partnership in batting and bowling. Then comes message passing. Now graph neural network uses a process called message passing to update the features of each player node in the graph. And this involves passing information from a player node to its connected neighbor and updating the player's features based on the information received. For example, the information from a batting partnership could be shared between two players involved, updating their features to reflect their performance together. Then comes convolution. So after message passing, graph neural network applies a set of convolution layers to the graph, and these layers uses filters similar to those used in convolutional neural networks to analyze the graph and identify important features. Then comes pooling. So after applying the convolution layer, the graph neural network performs a process called pooling. Here, the pooling reduces the size of graph while preserving important features. For example, the graph neural network might keep the most influential players in the team based on their features. And the final step is to output a prediction. So in the case of analyzing the relation between the players on a cricket team, graph neural network might output a ranking of the players based on their performance, importance, and influence within the team. So to summarize this, we can say a graph neural network processes graph data by passing information between the nodes, applying convolutional layers to identify important features, and using those features to make prediction. In the context of cricket matches, a graph neural network could be used to analyze the relation between the players, which could have applications in team selection, strategy, and performance analysis. Then comes probabilistic neural networks. Now, these probabilistic neural networks are a class of neural network models that provide probabilistic outputs rather than deterministic one. So instead of simply classifying an input as belonging to specific class or outputting a single value, this probabilistic neural network output a probability distribution over the possible classes or outputs. So in the context of cricket match, probabilistic neural network can be used to predict the probability of various events occurring during the match, such as the probability of batsman getting out, the probability of bowler taking a wicket, or the probability of team winning the match. So let's take a simple example. Imagine a probabilistic neural network designed to predict the probability of a batsman getting out on the next ball faced. Here the network takes as input features like batsman's form, the bowler's performance, the pitch condition, and the current score. So the probabilistic neural network outputs a probability distribution over these possible outcomes, that is the batsman getting out, remaining not out, or any other possible outcome. For instance, the output may be a probability vector of length 3, representing the probabilities of batsmen getting out, remaining not out, or being stumped if applicable. So the probabilities of the vector will sum up to 1. And these probability neural networks are particularly useful in cases where uncertainty is involved, and it is essential to consider these multiple possibilities. They can provide a more nuanced and informative prediction compared to traditional deterministic models. So to summarize this, we can say that probabilistic neural networks are the neural networks that output probability distribution instead of deterministic values. In the context of cricket match, these probabilistic neural networks can be used to predict the probability of various events, providing a more informative prediction than the traditional networks. Then comes recurrent neural network. Now this recurrent neural network are a type of neural network designed to process sequential data, such as time series data or sequences of events. Here, the recurrent neural networks are particularly effective in modeling relations between the elements in a sequence. So let's take a simplified example from cricket match domain to explain how RNN work. That is, using the example of analyzing the run score patterns of batsmen over the course of innings. So first we will have a sequential input. The first step is to feed the RNN a sequence of events as input. So in this case, the sequence would represent the events of batsman innings, such as the number of runs scored at each ball faced. Then we have recurrent layers. We know that recurrent neural network use a set of recurrent layers to process the sequence, and these layers contain a memory element that allows the network to keep track of information from previous elements in the sequence. At each step, recurrent neural network processes the current elements of sequence, updating its internal state based on both the current input and the information stored in its memory. And then we have output layer. The final step is to output a prediction. In the case of analyzing the batsman's run scoring pattern, the recurrent neural network might output a prediction of the next score run or based on the sequence of events leading up to that point. So to summarize this, we can say recurrent neural network process sequential data by maintaining an internal state that captures information from previous state in the sequence. And this recurrent neural network uses these internal states to make prediction about future elements in the sequence. In the context of cricket matches, a recurrent neural network could be used to analyze run scoring patterns of the batsmen, which could have applications in coaching, training, and strategy. Thank you.